Hey guys, Ray here. Welcome to my channel. Welcome to the undercarriage of my RV. Today I am ripping out my old 12 volt sealed lead acid battery system. I've got a 2 volts on this 12 volt battery, so I'm sick of replacing these 12 volt batteries. So I'm gonna rip it out. I'm putting a 48 volt lithium battery in here, and I've got all the stuff to do it. I've got all the kit. I've got a clean slate to put everything in. Should be able to run my air conditioner at night without any sun for 5 to 6 hours. It's Friday and I've got 2.5 days to do it, and also putting the solar on the RV. But it's Friday, we're going out of town on Sunday at noon, so we've got 2 days to do it. Okay guys, before I show the rest of this build, I just wanted to mention 3 things that this 48 volt battery and power system is going to do that the 12 volt system can't do. The first thing it's going to do is supply power to any friends that come camping with me. I'm going to tell any friends I go camping with, I'm going to say, leave your loud generator at home. No need to load it into the back of your truck. I'm going to put a 30 amp plug on this thing so they can just plug into my RV. This can run 2 air conditioners, so plenty of power for any friends that come with me. So the second thing this thing's going to do is provide power to the critical appliances in my house in case the power goes out. With that plug, I can run an extension cord into my house and run my fridges and my furnaces. Our cousin that lived like an hour away had power go out for like 3 or 4 days, so they had to like run generators in their garage for like 3 or 4 days. It was really kind of a pain for them to keep their food from spoiling. So basically I could just pull this RV up to their house, just park it, and provide them power. I'm going to build it in such a way that even on storms, I should have enough power to run my fridges and my furnaces. So the next thing it's going to do, and here's a little sneak peek of what it looks like, is it's going to save money on my electric bill. So I'm going to have this wired into my house. I've still got to work through the details on how specifically it's going to hook into my house. But when it's parked on the side of my house, I'm going to connect it to my house, and it's going to supplement my power bill and reduce my power bill. So it should be able to pay for itself. But that'll be in upcoming videos. But it's all built around the basic power system that I'm installing right now. And so if you want to see how that works or the future videos, subscribe, and should be a fun project, multiple projects, but it's all built around this 48 volt power system. But anyways, let's continue with the build. Thanks a lot for watching. Here's the old battery we're gonna get rid of. I hate these things, I hate them. This thing lasted just a couple years. Let's take it out. Here's my kit. I'll include everything in the description. Try and make it all easy for you if you guys want to do the same thing. It should be pretty easy to do. Just going to mount the solar all-in-one charge controller power system right there. I'll mount my battery right there, and I'm going to have a combiner box right here with a solar shutoff switch, so I can install extra solar panels if I want to. Combiner box is optional. This video is going to mainly focus on everything but the solar on top, although I do have to install that in these 2 days as well. But this should be pretty simple. So I've done a lot of research, talked to a lot of people that have installed these systems, so I've got a really good idea on how I'm going to go from 48 volt to my 12 volt battery system as well. I got everything mapped out. It should actually be pretty simple, so I'm excited to do this. So let's do it. Oh yeah. Darn it. Not super level, but pretty good. All right, time to remove the old jerry-rigged 12 volt solar system I have installed here. I have these solar cables coming down from the roof, which is nice because I'll be able to reuse these. This is a old 100 watt solar system. And the solar wires just go right into there where my solar power system is going to be. Oh, yes. Oh. Yes. Wow. All right, all clean. Okay, so here's where the old 12-volt battery would connect to these terminals, and it would go to this junction box. My new 48-volt battery is going to sit right here, so I'm going to move this junction box over a little bit. Now what I have here is what's called a step-down converter, part of the solar kit I have. Basically, I plug my 48-volt battery to this side, and then on the output, this has 12 volts up to 30 amps on this side. This thing stated as 97% efficient, but I will be testing that as well. So this is 30 amps, and I measured how much power my slide outs use from the 12-volt system, and also my electric jacks, how much power these use. My slide outs use about 19 amps, and this uses about the same to raise and lower the trailer. Here this is 30 amps, so this should provide plenty of power into my 12-volt system here. So related to the 12-volt system, there's something called the converter box, which is very important. I'll tell you more about that in just a second. Yeah, let's first get this 48-volt battery in place. That's always helpful. 5-watt cable for this 48-volt battery. It's awesome. Wow, that's beautiful. Okay, so one of the benefits of a 48-volt battery over a 12-volt battery is you don't need the same size of cables. You can get by with a lot smaller battery cables. So these battery cables, these are 5-gauge. This is 5-gauge wire that came with the battery. So I did a test earlier. I was able to run my air conditioner and my microwave off this same type of setup, and you can do that all off 5-gauge wire. So unfortunately, these are a little bit too short for my use, so I've got to use these 2-gauge wires that I have around. It's a good looking battery right there. Before I get too ahead of myself, I need to actually, I figure I should probably hook these systems up and make sure everything works. So first off, let's hook this up. I've got some other videos showing more about these systems, but they're pretty awesome. Basically, they provide AC power. That's really the gist of it. And basically, they provide AC power. So the AC power comes out here, and you can plug in, and the AC can either come from battery power, it can be supplied from solar, or it can be supplied from an outside source. If you've got shore power available, you can plug your shore power in, and then your AC output will be supplied from your AC input. So it's the complete power system. And so the supplied AC can also charge the batteries, and the batteries can be charged from the solar system as well. So there's a lot of cool settings in this thing. But so there's settings where you can have your power come straight from your solar, straight from your battery, combination of both. Or if you've got power available and you don't want to run your battery down, and just in case there's an emergency, you can have it so your loads are powered straight from the grid power. So you can run the grid power right here, and then all your loads will be supplied from here. So I'm going to run this in here. want to have an insulated screwdriver when you're screwing these, when you're working with these wires, with these terminals in here. Okay, all hooked up. Here we go. Nice. Working. Okay, so the nice thing about these batteries is they have what's called a battery management system. The battery can communicate with the inverter, and the inverter can also communicate with the battery with this communication cable. It's called a closed loop communication. If the battery gets cold or frozen or it's really hot, it can tell it stop charging me or charge a little bit slower. Okay, so I was able to get the communication to work. So basically, plug it into that. And if you're only using one battery, you just put all the switches up. And let's see if I can focus here. The one switch is down. And then this cable hooks right into this side. And then in your settings, you go to setting number 5. Setting number 5, and select lithium. You want to select lithium Li 36 and then L01 for this specific battery. And then I'm going to hit back. And then I have communication with the battery. So this battery is showing that it has 54% voltage. 54% charge. If you go over here, there you go. It's also showing 54%. So that means I know I have good communication here. So that's awesome. Let's try it out. Let's plug it in. I've got 120 volts ready to go. So I got my plug. So this goes to my RV. Let's plug it in. Let's go see if my RV has power. Nice. My RV has power. Let's cook something here. Oh yeah. Tons of power from this thing. All right, so this is a 900 watt microwave. But in order to run this microwave, I believe it takes more power than that. So let's see how much power it's taking. I'll just fill some water, put it in here so it absorbs that energy. 30 seconds, let's try that. Okay, let's go out here and see. Whoa, that's awesome. Yeah, 1.45 kilowatts to run the microwave. Okay, so this is a gas or electric. And I think if it's a gas and electric, it's not a very efficient electric fridge. So if you get a straight electric fridge, I think they're a lot more efficient. So this one should be not very efficient. So I want it to be on auto detect, so it should detect the power. It should go straight to electric power. Let's go see. Microwave's off. Okay, so the fridge compressor is using 320 watts of power. Wow, I thought it would use more power than that. And it looks like my battery right there is at 49%. Not getting any solar power, don't have solar power hooked up. Okay, Let's try the air conditioner. I only have one air conditioner in this thing, so let's try that. Oh, my thermostat is on 12 volts, so I need to hook up that still. So I'm just gonna jerry-rig this air conditioner. This is a little 12 volt battery, and I'm hooking the negative to a frame, and then the positive I'm just gonna hook to this jumper cable. Yeah, this is where it connected to the positive of the battery before. So I should have 12 volts. Okay, here we go. Air conditioner. Fan should turn on first and then the compressor. Oh, I think it just turned on. Had this to heat up the thermostat. Yeah, so the fridge is running and the air conditioner is running right now. So that's awesome. Let's go start the microwave. I'm gonna go 1 minute. Oh, it's running. Yes. 2.74 kilowatts. That's almost the 3,000 kilowatts that this thing can handle. 91%. It's running at 91%. That is so cool. Yeah, that's warm. So I'm not sure what else I can run, except I just did think of one more thing, and that's my TV and my DVD player. So I did another video review of the Growatt, and I maxed it out, and pretty much it just beeps if you try and pull more than 3,000 watts of power for like 5 or 10 seconds. It'll just beep and it'll turn off on you. So that's what it does if you pull too much power from it. Now, one thing important also to note is that there are capacitors in this all-in-one inverter, and because this is a 48 volt battery, there's a lot of power going from here to here. So if you turn this on and everything and then connect the cables, it'll probably blow your capacitors in here. So basically what you do is you turn everything off, and then connect your battery terminals. You turn your breaker on. There's a startup process here when you start it, and it'll slowly bring power into the system. So it'll run a pre-charge resistor circuit that slowly allows power to go in on startup. And then, yeah, this will beep for a little bit, but then it just starts and everything's good. So you don't want to just willy-nilly switch this thing on and off, because you may damage your unit here. Just be a little more careful with that. Let's put it in for real this time. All right, we've got our battery in. We've got our converter to step down to 12 volts. Now this battery is designed to go inside of a server rack, so you can wheel it around your garage or whatnot. So I still need a strap. I got room for one more if I need to put two in here. Here is the combiner box. The solar is going right down here. So this box allows for 4 strings of solar panels to be hooked in. All my panels on my roof are just going to be in one large string, but I can add more in the future if I want. And then I can turn off my solar power just by flipping this switch, and then I'll be able to work on any of my equipment without worrying about being shocked if the sun's out. So all these solar strings are combined, and the positive and negative will come down here. They'll go right into my solar connections right there. So I think we're getting pretty close. All we have to do is just wire these items all together. Okay, here is the step down converter. So this goes from 48 volts down to 12 volts. So the two skinny wires, these will hook into my 24 volt or 48 volt battery right here, black battery. And then these thicker wires, they go to they'll go to where the 12 volt battery used to hook up to. So this terminal used to go to the positive of the 12 volt battery. I'm just going to connect it right here, and then the old 12 volt battery hooked to the frame of the trailer. So I cleaned this off a little bit and I just stuck this negative 12 volt lead right to the frame of the trailer. So the 48 volts going to come in and then 12 volts going to come out. But before I hook the 12 volt up, let's go look inside the RV and look at the converter box and see how this hooks to my 120 volt system. So instead of plugging into shore power, I'm now going to plug into this system. This has enough power to run my entire RV. I'm going to plug into there. Here's my shore power plug. I'll show you this. This goes right into there. So let's go inside and look where this hooks into. Okay, here's my breaker box. I've got my 120 volt breakers. And I've got my 12 volt fuses right here. Always double and triple check that power is off. So here's where my shore power plug comes in. This feeds 120 volts in. Make sure power's off, obviously. There's 3 wires that come out of that black cord. So there's the green ground, hooks into here. The white neutral hooks into this bus bar. And you also have the black. Now the black sends, this sends live 120 volt power up to this breaker. So this supplies power to this metal bar right here. And all of these breakers hook onto that metal bar, and then they send 120 volt power to each of the 120 volt appliances. For instance, air conditioner, the microwave, TV, the outlets. Okay, I just plugged the RV into shore power, 120 volts AC. And from that metal plate, there's also 120 volts. So when you plug into shore power, you can charge your 12 volt battery. That's done with the converter box. So here's my converter box. Yours might be a little different. The converter box takes 120 volts right here with this black wire coming down, goes into this box right here. This box converts the 220 volts to, 13.6 volts or whatever to charge my 12 volt battery. So this red wire is what comes out of the converter box. This is at 13 volts. Here's the ground. This one goes right to where my battery was. My 12 volt is supplied from this line, and then it goes through all of these fuses here. So from my 12 volts, I can power my lights, my slide outs, my furnace, my stereo, and my electric jacks. So I'm going to want to turn this converter box off, and I'll show you why. All right, so basically I have my 48 volt battery here, 2 terminals, and then I have my step down converter box. I'll supply this with 48 volts, and the output of this is 12 volts. From here, my 48 volts goes down and hooks into my Growatt. volts, and then from my Growatt I have 120 volts going out, and this is where I plug my RV right here to the circular plug. 120 volts going out, then it goes through the side of my RV and into my circuit breaker here, into my breaker panel. Got all my breakers here, supplying 120 volts to all my appliances. And then from here, I supply 120 volts to my converter box, and that hooks into my 12 volt system. this hooks into my 12 volt system. So this hooks into my 12 volt system and this hooks into my 12 volt system. So I have like this circle here. I don't want any of my 12 volt appliances to receive power from this loop, because this really isn't very efficient. 48 volts down to 120 volts back to 12 volts. And this still supplies 12 volt power to my fuses on my 12 volt appliances. So here's where my converter box goes in here, right there. So I'm going to turn this off. Actually, I'm probably going to turn off the power and unscrew that and maybe just put a wire nut on the end of this so this doesn't get tripped on accident. Okay, now that this is off, let's go hook up the 12 volt. Let's hook up the 12 volt system right here. Let's hook this up. Here's where my old 12 volt battery used to hook on. Hook these together. My negative 12 volt hooks onto here. It's touching the frame really well right there. And let's hook the 48 volt side up. This one's not quite long enough to reach. Okay, it's all hooked up. Let's try it out. Okay, try the jacks. That is so cool. Let me try the slide outs. Okay. Yes, they are moving. Nice. That's awesome. So that converter box can only output 30 amps. And this one slide out's using 20 amps. So I don't think I can use them both at the same time. Let's see what happens here. There's that one. So you can use them both at the same time, but it's really slow. If you want to do multiple slide outs at the same time, you probably need the 40 amp step down converter. Wow, this is awesome. My lights. My thermostat's working from 12 volts. Stereo's working. That's awesome. Water pump. All right, I'm just gonna turn all the lights on and see how much power I'm using. All right, I have 17 LED lights on and whatever else is running on the 12 volt system. Let's see what it is. I guess I need to measure amps. DC amps. .5 amps right now. Yeah, 0.5 amps coming out of the battery. So this is a 100 amp hour battery. So it should be able to run all the lights on. They should be able to idle with all the lights on for 200 hours. All right, let's see how many amps are coming out into the 12 volt system. Almost 2 amps, 4 times as much, which makes sense. So just looking at those numbers, it looks like this thing's very efficient at low voltage. This thing's not using hardly any power. Now it has these fans on there. Imagine that's for when you move the slide outs, and it would probably get a little bit hot. but I don't use the slide outs that often, so I'm fine keeping this here. This shouldn't be using, this isn't using hardly any energy. Okay, here's the basic wiring. This is a little strap I found, but it's probably not strong enough. This is like a 100-pound battery. So I think I'm gonna get some of those like metal earthquake straps you put on water heaters and strap around here. That would probably be a lot better for I think I might do that. Positive, negative communication cable. Okay, so my shore power is always going to be plugging into here. It's never going to plug into short anymore. And if I ever have grid power available, I can use this plug I just wired in. And this one is just going to be used to charge my battery. I can run everything off this plug right here. So let me just try and use this right now. So obviously I could wire a bigger plug here, but I don't think I'm ever going to use this. I'll have enough solar, I don't think I'm ever going to use this plug, but let's just try it anyways. Okay, so this is kind of interesting. So I've got my electric fridge on right here, and when the default setting is, it looks like if you plug into utility power, use the utility power first, and it just does a bypass, and it just powers my utilities, powers my loads inside my RV with utility power, and then the extra power is just going into my battery. So right now the default setting is it charges the battery with 30 amps, and at I think it's 54 volts, and I've got 120 volts coming in at 18 amps. So that could be a little bit of a problem for me. This plug can only handle 20 amps, and I think my breaker on my house is 20 amp breaker as well. So if I turn my microwave on inside the RV, it's going to go over the 20 amps here. But I think I like it using the utility power first if I have it, I think. But I'm just going to make it so it trickle charges the battery. So I'm going to go in setting 11. Okay, in setting 11, instead of using 30 amps, I'm just going to go with 10 amps. Okay, now I have 10 amps coming in, and I'm only using 7 amps. So that should prevent my cord from being fried, or my breaker from flipping on right here. So now whenever I'm plugged into utility power, it'll just trickle charge my battery and everything will run on the load. I think I'd like it running off utility power first when I am plugged into utility. Right here. Instead of having this plug, I'm gonna wire this, have a wire go out here, have this out here, right there. And I think I'm gonna actually hook 2 of these right here. And so if I have my friend comes camping with me and he needs power, he can just plug it into my RV. So they'll both come from the same outlet. Totally safe, because if I ever go over power, this thing automatically shuts down. If he tries to turn on both of his air conditioners and then I try and turn on my air conditioner, then this thing will just shut down. So that'll be cool to provide power to anyone that comes camping with me as well. So also with this combiner box, I can also use these plugs to provide power to my critical appliances in my house. That's one thing I'm planning on doing, and I'll do a test on that later on. But so this solar power from the roof, this string, I think I'm going to have 5 large panels on the roof, 1500 to 2000 watts. And if there's an emergency, I'll have power. Solar panels can still produce energy when there's clouds, just not as much. So basically, I can just have a makeshift ground array using these used solar panels I got from Sandcan Solar, and I can just set these up maybe along the back of my fence here, And then I can plug an additional string of panels in right here for power on shady days, and right here and right here. 6, 12, 18 more panels on cloudy days. And I should be able to run all my critical appliances on my house in cloudy conditions or stormy conditions, but I'll have to do another video on that and test that. That should be pretty fun, having plugged my house into my RV. That'll be really cool. So another thing, when I plug this into the back of my truck and I'm towing, driving around, this thing is providing 12 volts from the alternator into my RV. So yeah, lithium batteries and alternators don't play nice together. So I'm gonna actually just disconnect that hot where it comes into my RV. Comes into this box. So this is where the truck alternator 12 volt power comes from, and I just put a wire nut on there. So no, I shouldn't be getting any 12 volt power from the truck either. Okay, so we got back from California. I wasn't able to get the solar panels on the roof, but I was able to use the battery system. After using it for a week, there is some things I definitely want to change, and I'll show you that. When we were on the road, my wife said, hey, I need to get the DVD out of the DVD player. I said, we can't because I have to plug this in. So it's kind of annoying. So I'm going to take this out, run it like underneath the RV. It'll come up here. And then if I ever need the inverter on, I can just switch it right here. This is the switch. I don't know if you can see that. There's a little toggle switch right there. So I think I'm going to take this, see this little toggle switch? I'm going to take that out, hook into those two wires right there. I extend those two wires into my RV somewhere. So when I'm in the RV, I'm able to turn on and off the inverter. So another thing I want to do as well is add this. This is called a Victron Smart Shunt. I don't know if you need to specifically buy the Victron. This is the kind of expensive one. You just hook it right onto the battery terminals, and it measures all the energy coming in and out of the battery, so you can know the battery state. And it also has a cool app where you can see how much power is coming into your battery, for instance, from your solar panels. So with this, I'm not going to need like a little display on the side of in my RV. I can just pop open my phone, open the app, and just see all the data associated with my battery. And so I used this before. It's really nice. I have another video where I hooked this up and I used it for the first time. I just want to talk a little bit about the inverter, selecting the right inverter. So my inverter is the Growatt 3048P model. And I selected that model because I'm able to put more solar panels in a string configuration. The solar charge controller can accept a higher voltage. And that'll be nice for me if I want to hook up those extra 18 panels. They'll be really easy to hook up. I can just hook up a string of 6, another string of 6, and another string of 6. But I think most people would be better to get the Growatt 48P version. I have the ES version. I think most people would probably, I think the 48P version would be better because you don't have this huge solar array on your roof. You only need like 60 volts, which is like, if you put like 2 panels on your roof, you should have enough voltage in order for that solar charge controller to operate. It operates between 160 volts to 115 volts. So I know there might be some people on here that would say, well, why don't you get the Victron? I think they have what's called the Multiplex 2, which is kind of the equivalent of the power system I have. It's not really a full all-in-one system because it doesn't include the charge controller, because you have to buy that separately, but more or less includes everything else according to my understanding. But the Multiplex 2 3000, it's a little bit deceiving because that doesn't have an output of 3000 watts. On the spec sheet it shows 2400 watts of the output power for that inverter, so that might not be able to run everything on my RV. I know they have a feature where it can like supplement power from shore and from the battery if you have like a really big load. But for me, that wouldn't work because I don't want to supplement power. That means I need to be connected to the grid, but I don't want to be connected to the grid. I want to have, I want my system to be able to power everything off when I'm boondocking. So another reason why I like the Growatt system is it's just so much simpler than the Victron. Whenever I see the Victron systems, it seems like there's wires strung everywhere, and it seems pretty intimidating to hook up. Yeah, but if I can hook this thing up, you guys can for sure. You saw me hook this up. I didn't do anything special. It's working great for me. This battery, I have room here where I didn't have room before. So before I had the battery and then like the air vent, and this battery's taking up about the same amount of space, but it has right around 8 times more capacity than my sealed lead acid battery. So this is about the equivalent of 4 Battleborns, 12 volt Battleborns. I know sometimes people build their own lithium battery, but this is really nice because it has handles, it has this nice case. If you're using too much power, this will break. So this actually has double protection, so if you're pulling too much power out of this, the BMS will shut it down, and if the BMS is broken in some way, this will shut it down. So it's like protected that way as well. So here's another battery that's available. I was going to recommend this battery because it's about the same, it's the same size, but it's about $250 cheaper. So I was going to recommend this one. And I actually even hooked it up into my RV here. And I took it to California. But in California, I tried to use the air conditioner on this, and this would not start the air conditioner. I had to charge this up to full power, and then it was able to start the air conditioner. But when it went down to like 85% charge, it wasn't able to start the air conditioner. Yeah, I should probably install a soft start on my air conditioner. I think it's like $250, but I think I'm going to use that other battery for now. But this battery would work if you wanted, if you hooked 2 of these batteries together and hooked them in parallel configuration, and then it would be less of a drain on a single battery. Yeah, I did a video where I was testing the inverter idle power usage, if the inverter's just on doing nothing, and that was like, I think it was 50 watts when the inverter's just idling. So if this idles at 50 watts, and this is a 5.12 kilowatt hour battery, this should be able to idle for like 100 hours. So I might just keep my inverter on when I'm out camping. So I got tons of battery power. So I'm not an electrician, but if you have any comments, I'll do my best to answer any questions you might have. So guys, thanks for watching. This was a really long video, but as a reward for watching to the end, I'm gonna give you a discount code for the used solar panels if you want to get them from Santan Solar. I'm working on getting a discount code from Signature Solar for all this equipment. If I get it, I'm gonna just put it in the link down below, and or if you call them, let them know that I sent you. Thanks a lot for watching. I'll keep you updated on how things go. Have a good one. See ya.